Good day, architects. Today, I am going to present my thesis study which entitled Proposed Redevelopment Plan of Daniel Z. Romualdez Tacloban Domestic Airport, an analysis on the relevance of disaster risk reduction in airport design. These are the list of all domestic airports under Civil Aviation Authority of the Philippines, CAAP, and the top two disaster-prone airports according to CAAP are Tacloban Airport and Legazpi Airport. Here are the problem statements that needs to be answered at the end of the thesis study. First is, what are the factors affecting in selecting domestic airports of entries? These factors are the ones that set the standards in selecting domestic airports. Next is, how can we mitigate the disaster risks in terms of designing and building forms through architecture? A thorough research not only of the site, but also the design concepts that lessen disaster risk. Last but not the least is, what are the elements that should be prioritized in this type of project? These are the considerations that should be noted when designing the airport. The significance of the project discusses the thesis study will produce design concepts and architectural solutions that will help and contribute to the field of architecture and airport design with relevance to disasters in the Philippines, which can help lessen the devastated airports in the country. Site A is Tacloban Airport, which has a lot area of 134.32 hectares, runway length of 2,138 meters by 45 meters, apron of 230 meters by 80 meters, passenger terminal building of 1,622 square meters, and cargo building of 180 square meters. Site B is Legazpi Airport, which has a lot area of 132.28 hectares, runway length of 2,380 meters by 36 meters, apron of 200 meters by 100 meters, passenger terminal building of 910 square meters, and cargo building of 210 square meters. These are the environmental settings that must be considered in the site of the Legazpi Airport. Site C is Ross Airport, which has a total passenger movement of 2,815,331, total aircraft movement of 26,349, and total cargo movement of 36,185,595 from the year 2003 to 2018. The chosen site was Site A, Tacloban Airport. The climate type of the site is with rainfall evenly distributed throughout the year. The lowest rainfall occurs during the months of April, while the higher rainfall occurs in the months of October up to February. The site experiences a daily air temperature between 25.8 degrees Celsius and around 28.2 degrees Celsius in the month of May. The wind directions in the city are northwest from July to March, south to southeast from April to May, and southeast during the month of June. The city is located in the lowland basin known as Tacloban Basin, with a land area of 2,500 hectares, and it also has an elevation of about 3.05 meters above the mean sea level. The site is located in an area classified to be of quaternary alluvium, where rock units overlies most of the older rocks. The site is also underlain by compacted young sand deposits. Various soil types are found in the city, but most of them are Pawing Silt Loam. Tacloban City is close to the Philippine Fault Zone, a major earthquake generator. The site and its vicinity are relatively flat. The limestone deposits in the city are Oleocene and Pleistocene, and late Miocene to Pliocene limestone. Water from the well within the airport facility is being used as a source of drinking water at time when Metro Leyte Waterworks doesn't work. And there is no soil contamination in the site since all fuel tanks were constructed above ground. According to the CAAP, the study mentioned in this slide concludes that a new passenger terminal building needs to be constructed because the existing structure is inadequate to handle forecast air passenger traffic breaches the obstacle limitation surfaces, and not ideally configured for the efficiency. The total number of parking spaces is insufficient to accommodate the number of vehicles during peak hours. The pavement surface is in a stage of wear and tear. There are no pavement markings for parking slots in traffic flow direction, and there are no designated public parking areas for the airport use. Without the expansion and improvement of Tacloban Airport, aircraft movements will be limited. With the current increasing demand of tourists to Tacloban, passengers will have to use sea transport for them to reach their destinations. Listed on the table is the data of affected passengers traveling plane instead by sea will reduce travel time by about 21. The table shows the terminal building due to volume capacity during peak hours. It has a total passenger movements of 12,760,803, total aircraft movement of 150,034, and total cargo movement of 86,254,477 from year 2003 to 2018. It also shows the peak hour passenger movements of departure and arrival and its daily air passenger volume in December, which is the busiest month of. The types of airplanes used in Tacloban Domestic Airport are small jets, Airbus A319, A320, and A321. Airbus A320 is the most used airplane in the Tacloban Domestic Airport. The standard runway length is 2,100 meters to 2,500 meters, and the runway of the airport is 2,138 meters. The drainage system at the airside cannot be determined because the canal is along the runway and the existence of tall grasses is a big factor. While at the land side, surface runoff is collected through road inlets and manholes, discharging into the main drainage line to the north side of the terminal area. The cargo terminal building of the existing airport is 1,026 square meters, which is adequate for the medium-term requirements since the minimum cargo terminal gross building area is 688 square meters according to the. So these are the solutions and concepts that can help my thesis study. First is considering the building shapes of the terminal building. The site is very close to the sea and according to my research, building shapes letter T, letter L, and letter U are more prone to devastated compared to a linear shape of building as they produce wind pressure gears through to. Next is consideration of not having twin roof as the roof of the terminal building because it creates gable walls directly open to. The long rectangular plan was applied in the design because it produces lengthy gable barriers which can make the building more stable during typhoon. These design concepts can help my thesis study to become more wary in disaster risk in designing a terminal building beside this. So this is the existing site development plan of Daniel Z. Romualdez Tacloban Airport. The passenger terminal building is inadequate to handle forecast air passenger traffic, especially in peak hours, and the building is only 276 meters away from the seaside, while the parking area is also inadequate to handle more passengers going in and out of the airport. The apron is also inadequate to handle more aircrafts landing and departing due to its peak hour passengers. The passenger terminal building was inspired by the Tacloban festivals such as Subiran Regatta, a sail festival which uses sails without paddles, and Taclob, a bamboo contraption used to catch seafoods in the festival. The concepts were applied in the exterior columns of the passenger terminal building, a sail with a touch of bamboo material. So this is the proposed site development plan. The site was expanded. The existing passenger terminal building was expanded also from 7,050 square meters to 12,400 square meters, which can accommodate more passengers coming in and out of the airport. The existing parking area was also expanded from 1,710 square meters to 13,448 square meters, which can have more parking slots not only for the passengers, but also for the staff and employees of the airport. The existing apron was also expanded from 18,400 square meters to 33,600 square meters to have more airplanes embark and disembark in the apron. And the existing cargo building has been transferred because its building area is adequate for cargos. According to the CAAP, the lots used in expanding the airport were government-owned lots. The existing road that will be covered by the site expansion was only an access road built for the existing airport only. It won't ruin any connections of the other roads. The road in the front of the new proposed development plan will be expanded and be the main airport road. A proposed sixth-floor control tower was also designed beside the passenger terminal building, and the future expansion for the site is also beside the terminal building. So this is the ground floor plan of the proposed Tacloban Airport. So from the aircraft, there is a movable boarding stairs attached to the aircraft for the passengers to come down. And then they will go to the baggage claim area where the baggage are released from the aircraft. And then exit to the arrival area where retail stores are there in case the passengers want to buy something for their loved ones. The passengers meet and greet area is in the garden wherein it is enclosed because it can also be an evacuation area in case of emergency. The admin offices are also located in the ground floor and the crew offices and lounge are also in the same floor. The transfer desk area located at the right side of the building is an area wherein the flight attendants and the crew will be transferred to a shuttle going to their designated aircrafts. The curbside area has private vehicles and public vehicles designated separately in order not to cause vehicle traffic if it is combined. So this is the second floor plan of the proposed Tacloban Airport. For the passengers, from the entry to the first security check, going to the departure hall where information desk, baggage rack, airline offices, public toilets, clinic, lost and found and security offices are located. The passengers can go through the garden but they have to show their tickets to the guards before entering. The passengers can also self-check-in if they don't have any luggage with them, so the passenger flow will not be congested much. It has 2 queuing area and 8 check-in counters as computed per 112 peak hour passengers. Then, the passengers will have to go through the final security check. They will now have the access to the restaurants, food kiosk, retail store, and VIP lounge for those who are in business class members. There are 5 gate lounges located in the hall which connects to the airside corridor going to the boarding bridge and to the aircraft. There is also an interior ramp in case the boarding bridges won't work in some time. There is still an option for the passengers to go down using the ramp and exit to the ground floor and use boarding stairs to embark in the aircraft. The visitor entry is in the right side of the facade of the terminal building. This commercial area is for the visitors and passengers to have more time with each other if they are early in their respective flights. The passengers can access from the commercial area to the garden and to the departure hall while the guards check their tickets. The visitors cannot enter the departure but they can enter the garden which is enclosed and can be an evacuation area in case of emergency. This is the aerial view of the second floor of the passenger terminal building, which the departure area is located. The roads for private and public vehicles are separated to avoid vehicle congestion. This view shows the detail of the exterior columns, which represents the sail and bamboo, and inspired by the Tacloban festivals. This view shows the proposed 6th-floor control tower beside the passenger terminal building with airplanes lurking behind it. This view shows the first floor of the passenger terminal building, which the arrival area is located. The roads for private and public vehicles are also separated to avoid vehicle congestion, and the road of the parking area was also shown in this view. This view shows the interior perspective of the queuing area of the check-in counters at the second floor, which is in the departure level. This scene shows the check-in counters at the second floor highlighted by the space frame and skylight roofing, which makes the building efficient through its source of light. This view shows the garden at the second floor of the terminal building, which is also highlighted the space frame, which can be hooked up industrial lights exclusive for the plants. So these are the food kiosks near the gate lounge wherein the passengers may dine while waiting for their respective flights.